How large language models are trained and why that matters. Before we talk about how large language models, also known as LLMs, are trained, it's important to set expectations. These systems do not think, reason, or understand. They're trained to generate language based on patterns and data. So as we walk through this process, the goal is to understand how the way these systems are built explains both what they do well and why they have certain limits and risks. Now, this image shows the main stages involved in training large language models step by step. There are 5 general stages, starting with data collection, pre-processing, embedding, pre-training, and fine-tuning. Now, everything starts with data. Large language models are trained on massive amounts of text drawn from a mixture of publicly available sources, licensed material, and text intentionally created or curated for training of these LLMs. Now, before training begins, this data is filtered, deduplicated, and weighed, usually through automated processes designed by engineers. These early choices shape what the model treats as normal, common, or important. Now, unlike humans, the model doesn't know which sources are more credible or more accurate. It learns patterns based on what it sees most often. So issues like bias, missing perspectives, and representation aren't added later. They're shaped by these early data choices. Now, once the data is collected, it has to be prepared so a computer can work with it. And this stage is called pre-processing. The text is broken into smaller units called tokens and converted into numbers, which is the only language computers understand. This makes large-scale training possible. But it also means that tone, context, and nuance aren't explicitly preserved. They have to be inferred statistically later. When complex human language is reduced this way, meaning can shift, especially in emotionally or socially sensitive contexts. After the text is prepared, the model begins learning relationships between words, and this is the embedding stage. Now, at this stage, tokens are turned into vectors and placed into a multi-dimensional space. You can think of this as the model's internal map of meaning, built entirely from patterns of which words tend to appear together, but not from any real understanding. If certain ideas appear together often in the training data, the model treats that association as meaningful, which may reflect reality or, in some cases, bias. Now, over time, those patterns become structural. Once this internal map is in place, the model begins its core learning task, and this is the pre-training stage. The model is trained on billions of examples to predict the next word in a sequence. This is statistical pattern matching, not reasoning, judgment, or comprehension. In practice, this means the model can produce confident-sounding language even when it doesn't have reliable information to draw from. If it hasn't seen a situation before, it doesn't pause or ask for clarification, it still predicts the next word. That's why these systems can produce fluent but incorrect or fabricated responses. Not because they're lying, but because they don't recognize when they don't know. At this point, the model can generate language, but it hasn't yet been shaped for use. This is done in the fine-tuning stage. Now, after pre-training, the model is further shaped using carefully selected examples and feedback. Now, that feedback can come from people, automated systems, or other models that reflect earlier human decisions through processes like instruction tuning and reinforcement learning. This stage isn't mainly about teaching new knowledge. It's about shaping how the model responds, what kinds of answers are preferred, what to avoid, and how responses are framed and expressed. Now, because this guidance ultimately traces back to human choices, fine-tuning reflects human values, assumptions, and judgment calls. Those choices influence the model's behavior, even though most users never see how that guidance was created or applied. Now, across all these stages, one thing remains consistent. These systems are powerful because they learn from large-scale patterns in human language. But that also means they carry forward human gaps, distortions, and blind spots. Nothing about how these models are trained gives them judgment or responsibility. Because of how they're built, their usefulness and their risks always go together. Using AI well means being thoughtful about how much trust we give it. Every time we use its output, we're extending trust, so it's important not to assume it's always right. But it's also important not to assume it's useless either. What we know about how these systems are trained should guide our expectations, so we use them ethically, responsibly, and as support to, not as a substitute for human judgment.